Good day, friends. Today I am here with the new video regarding the boiler burner. Today I am going to discuss the types of burner, especially the pressure jet burner and the rotary cup burner. In this video, this is the part one. I am going to discuss about the uh, pressure jet burner, that working principle, the diagram of it, and another part I am going to discuss the rotary cup burner. Here you can see types of burner. This is being classified as per the fuel which is being atomized, because when the fuel is going, it is being atomized by two main methods. Number one is your pressure jet fuel oil burner, and number two is your rotary cup fuel oil burner. These are the major two types utilized on board ship. Here the description of the pressure jet fuel oil burner. As you can see, the pressure jet fuel oil burner basically consists of a burner barrel which is attached to the swirl plate and orifice plates. So these are the two plates which is attached to that, and this complete assembly is held up in place by the cap nut. So cap nut is required because whenever we are going to do the maintenance of it, we are going to remove it. So this cap nut is keeping them place. The unit is clamped to a burner carrier which is attached to the boiler casing. So basically the boiler burner casing is attached with this. The pressurized fuel, there is a connection on the line, you can say, through which the fuel oil is going to pass, and it is supplied to the burner with that fuel oil line. All of this, whatever I am telling you now, is going to be described later in the diagram. As the oil passes through the angled holes, actually which is there in the swirl plate, they acquire the rotational energy. So that rotational energy is going to create basically later on, once it comes out of the burner, in the form of a hollow rotating cone. As you can see, the rotating oil stream is forced through the small hole in the orifice plate, and this causes the fuel jet to break up into very fine droplets, and this creates a hollow rotating cone as the oil leaves to the burner part of it. So this is typed over here in the diagram. As you can see, I will just show you with the laser pointer that here this boiler casing, this is your boiler casing in which this boiler burner assembly is being attached. Through this locking handle screw, this is keep in place, and this is your complete boiler burner. Okay, and this is your burner carrier, as you can see in the diagram. Here the fuel oil supply pipeline is going to be attached, and through which, this is the central pipe through which the fuel oil is going to be passed over here. And here you can see the swirl plate arrangement in which you can see the angled hole is being provided, and you have the orifice plate also fitted in which you have the small hole which is being provided. During the maintenance we have to clear this out, because when the heavy fuel oil is being used, finally this is going to be choked, not completely, sometimes partially also. Okay, and this is the cap nut which I was talking about. This cap nut is completely keeping this, the swirl plate as well as the orifice plate, into the place. Now I will do more elaborative explanation of the pressure jet fuel oil burner. You can see it consists of a steel tube or barrel, which we have seen. The material utilizes the steel tube, and the orifice plate is also made up of a high grade of alloy steel. Okay, and when we talk about this, this is attached with the burner carrier, and that is attached with the boiler casing with the held up screw that we have seen already. And this both holds the burner in a very correct position relative to the furnace. And also it permits to the supply of fuel oil through oil tight connection. The connection has to be oil tight because we don't want any oil leaked in the furnace area. So that is kept in mind. Okay, and other one major information which is provided over here is that the safety device which must be fitted in order to prevent the oil being turned on when the burner is not in place. So you must have observed that when you swing out the burner, there is an alarm coming which is called burner not in place. So this is something which is a safety interlock provided, and this does not allow the fuel oil to pass through when burner is not in position. As the oil is pressurized and passing through this, this is performing basically the two major operations. Number one is your rotational energy, as I have told you, as the oil is passing through the angled hole in the swirl plate. So the swirl plate which is having the angled hole, this imparts the rotational energy, and then this rotating oil is passing through it. Okay, as you can see the detail of the pressure jet burner, I'm going to tell you again and show you again with the laser pointer. You can see over here, this is the variable oil supply with the pressure it is coming over here, and you can see again this the swirl port. Here the oil has to go through this angle port, and this is imparting the rotational energy, and this is the swirl chamber. Basically, as you can see, this is the swirl chamber, and this is the orifice split, and here you have the small orifice which you can see. And when the oil is passing through here, this is going to get the rotational energy, and through this orifice it is going to go and create the hollow rotating cone as it atomizes. You can see hollow rotating cone is formed with the oil droplets which is atomizing it, and this is the atomizing orifice you can see here. And this complete assembly is being kept or held in place with the orifice plate, with the cap nut, as you can see on top of this. Okay, so this is the detail of the pressure jet burner nozzle, as you can see in front of it. Here, when we talk about this, the small hole, the orifice plate causes the jet to break into fine droplets. So two things happen. Number one is the rotational energy, which is being provided by the angled hole, and number two is the orifice, which breaking the fuel into fine droplets. So atomization as well as the creation of the hollow rotating cone, that also happened. As a final result, the hollow rotating cone is being formed, and in this one, many other variations also exist in the form of design. Depending upon the manufacturer, this is being done. Okay, this type of oil burner control over throughput of oil that is obtained in the two ways. By varying the oil supply pressure, suppose we have to increase the throughput, we have to increase the oil pressure, or by changing the diameter of the hole. Okay, so if the hole diameter is being changed, definitely the flow will change, or the quantity through which the hole allows the fuel to pass. So that is also being, so there are two ways. Number one is your oil supply pressure increase, or otherwise the diameter of hole to be increased. So there the throughput is being maintained by these two things in the pressure jet burner. Limitation exists which prevents either method being used as a sole means of control to wide range of throughput, as we have discussed also. The ratio of the maximum to minimum oil throughput of the burner is known as the turn down ratio. Sometimes in the oral it is being asked what is the turn down ratio in the boiler. So it is showing that the maximum to minimum throughput of the burner, this ratio is called turn down ratio. In case of the pressure jet burner, this can be stated in terms of the square root of the ratio of maximum to minimum oil supply pressures. In all pressure jet burners, minimum supply oil pressure in order 700 kilonewton per meter square is necessary to ensure the efficient automation it is being maintained, because this much is required to create the efficient automation. Otherwise, you will not get the proper flame of it, or the proper combustion is not being possible. At the time, the various practical consideration, if you see that, then the maximum is approximately 7,000 kilonewton per meter square also. And in that case, the turn down ratio will be approximately 3.5. Okay, the wide range of turn down is required in a system to incorporate a number of burners which is being used. If you see that for the tankers and all, you have the high firing burner, low firing burner, all these things are there in that system, basically to have the overall turn down on the basis of number of burners in the operation. Sometimes you have four burners also in the boiler. Okay, for changing an orifice size in addition to the variation in the supply pressure considered above. However, while this system is convenient for the manual operation, it is not suitable for the automatic control due to the need of change of orifice sizes when the oil supply pressure reaches to the upper or lower limits. Okay, so this is something which is description of it, or you can say these burners must be kept clean when we talk about the maintenance part of it, and care must be taken during this operation not to damage or scratch the finely machined surface of the swirl and orifice plate. So when we are doing the maintenance of it, we have to be very very careful that there should not be any scratch created to this orifice plate as well as the swirl plates, because these are very finely machined parts and it is going to change this throughput. Suppose you are clearing the whole of the orifice and it is being enlarged, generally it is not, but you have to take care of it. The later should be renewed as you find that orifice wears out due to a certain amount, because continuous the hot heavy fuel oil is passing through it, so erosion will happen and somehow it will be enlarged, so it needs to be replaced. This should be checked at regular interval by means of a gauge. Okay, after cleaning, make sure that all various parts are being correctly assembled. When we are doing the maintenance, we have to clean, and especially the threads and all, it has to be perfectly clean so that it will assemble correctly. Any oil leakage must be rectified as soon as possible, and otherwise what will happen, it will leak into the furnace and cause the fire inside it. Okay, the air resistor or double casing of the boiler have also included into the fire part of it. Burner not in use should be removed. Otherwise, the heat from the furnace will cause any oil remaining in the burner barrel to be carbonized. This is also a very important point, but generally it is not being observed on board ship that if the boiler is not in use, so they will keep open the burner and not in place, burner not in place. Otherwise the heat which is generated inside the furnace, that will carbonize the remaining oil inside it, the boiler barrel, so burner barrel. So this is to be kept in mind. Now, this is the last slide. I hope whatever I have described in this one is going to help you out for the proper understanding of the pressure jet burner, with the diagram also, which you can utilize for the exam purpose. Thank you all of you. And in the next part, I will come up with a rotary burner. Okay. Thank you.